Okay, so we're going to be looking at this question here and we want to find out if the series here converges or diverges, and this simply means that as our n here goes to infinity, what happens to this function? Does it reach a specific finite value, or does it go to infinity as well? If it reaches a finite value, then it converges, but if it goes to infinity, it means it diverges. So I'm gonna break this series down into two functions. I'm just gonna say let f of x be equals to 3 plus cos of x, and g of x is gonna be the denominator, which is n cubed. Okay, so what we're gonna do is we're gonna assess these two functions independently, and we're just gonna use a limit as x approaches infinity. And we're gonna start off with f of x, which is gonna be 3 plus cos of x. Okay, so the best way to go about this is to draw the function and see how it behaves at small values of x before we even go to infinity. So I'm just gonna sketch our f of x here. It's gonna use a dotted line here. This is gonna represent f of x is equals to 3, because this function f of x has been offsetted by positive 3, and this one is gonna be our x. I'm just gonna draw the cos function with amplitude of 1. It looks something like this, and then it goes like this. This pattern follows all the way up to infinity, because that's our cos function. It doesn't really blow up as x gets bigger. And here we're gonna have 4, and there we're gonna have 2. I hope that's easy to understand why we have that. So we want to assess the limit here. So we're not going to use too much math. We're just going to make a sort of approximation. We know our function can either be this whole function here, at best can be 4, and the lowest can be 3. But the cos function on its own, the highest it can have, our cos function, max is equals to positive 1, and the minimum is equals to negative 1, and that kind of explains why we have this shape and the values we have for the maximums and minimums. So the maximum for f of x, it's easy to see that it's going to be plus 1 plus 3, which is equals to 4, which is over there. So saying the worst case scenario for x would then be equals to 4. So, but since we have both a maximum and minimums happening every period, then we can just take an approximation of this function, our f of x, and then we can say that this limit here at best will happen at 3 plus the minimum is going to be we want an average of this, so we're going to have 4 plus 2, which is going to be divided by 2, so that's going to be 4 plus 2 divided by 2 is going to be an average. Oh, okay, sorry, I made a mistake here. So this is just for the cos. Minimum is minus 1, and minus 1 minus 1 minus 1. Okay, sorry, I keep making this mistake. Minus 1. We're just trying to get an average here, and okay, this keep making this mistake. Minus 1 plus 1, that's going to be our average, and then this is going to go to 0, and so we're going to get 3. That's going to be our limit as x goes to infinity for f of x. It's going to be 3. So now we go to the limit of our g of x as x goes to infinity, we want to see how n cubed behaves. And this is obvious because this is a polynomial of a cubic polynomial, so this will obviously go to infinity. That should be straightforward. One thing to remember is that we cannot use an identity here. We cannot use the small angle approximation such that cos x is equals to, I think it's 1 minus x squared over 2. No, we cannot do this. And this is because we are talking, this only works for when x is very small. So in reality, it's somewhere around here. When x starts getting bigger, this approximation is not true. So we cannot use it when we're approximating x to infinity. So we only use this when x is roughly still very much smaller than even 1, but still positive. And for convergence, testing for convergence, we want x to be very large. So this is called small angle approximation. This identity, which we say we cannot use here, while what we do here, this is for large values, large n. So now we have our convergence. We can go back to our original function up here, and then we're gonna say we can draw a conclusion. We'll say limit as n approaches infinity of sorry about that, of 3 plus cos n over n cubed is easily equals to we said 3 at the top and infinity at the bottom, and this is just 0. Therefore the series, you can just call this f of n, is convergent because it does not go to infinity as n goes to infinity. And we didn't have to use any fancy tool, but technically the test we used here was the convergence test, but we like to call it by inspection. I hope this made some sense.